So today we're going to talk about arc length and surface area using polar equations. The formula for arc length is lowercase s. Polar equations have angles, so I'm going to go from alpha to beta. Square root of, and this one's a little different than you're probably used to for arc length. It's the actual function squared plus f prime of theta squared, and then d theta. The equivalent of that, if you'd rather use r for f of theta, would look like this: alpha to beta square root of r squared plus dr d theta squared d theta. Okay, so let's try an example. I've got an example here. Let's say that r equals 6 times the sine of theta. And we want to do that from theta is 0 to pi. Now, normally you might think 0 to pi goes halfway around the circle, but this one actually goes all the way around. You can check that out by graphing it either on your graphing calculator or by hand. It's got a sine, so it's kind of around the y-axis, so it's oriented around the y-axis. The diameter is 6, so this actually goes all the way around the circle. So if you use geometry, which we're not going to, but we can use it for the moment, then we can say that it's 2 pi r or pi d, and that's going to be 6 pi. So we're looking for an answer of 6 pi. Now, let me do the calculus version of this. So let's go 0 to pi, and then we take the function. So the function is 6 sine, so 6 sine theta, and we square it. Then we need the derivative. Well, the derivative of 6 sine is 6 cosine, and we square that, and then d theta. So there's what we're going to integrate to get the surface area, or the arc length, 0 to pi. This is 36 sine squared plus 36 cosine squared of theta under a radical d theta, which ends up being the square root 0 to pi, square root of 36, because sine squared plus cosine squared is going to give you 1 in there. So this is actually just integrating 6. And that'll give us 6 theta from 0 to pi. 6 theta from 0 to pi is equal to 6 pi. So there's your arc length. Now, that is a fairly easy example, maybe not too bad, but it works fine. Here's the formula for the surface area. S, capital S, is equal to 2 pi. Surface area formulas usually have 2 pi in them. And then you've got alpha to beta, because you're working with angles. Then you take f of theta, and either sine of theta or cosine of theta. Two versions here. Let me show you this. This one's cosine theta. So f of theta sine theta, f of theta cosine theta, and then you put the piece from the arc length in there. So f of theta all squared plus f prime of theta all squared d theta. Now this one, same thing. F of theta all squared plus f prime of theta all squared. So here's the arc length piece, and this is going to spin it around the axis. Now, what axis are we talking about? That's the deal. This one is about what's called the polar axis. That's the old x-axis. And it's just because we're changing to polar coordinates that we're calling it the polar axis. That's the old x-axis. And this one is about theta equals pi over 2. An angle theta equals pi over 2, that's the old y-axis. So in case you want to know what's going on with that. Now, an example that I want to do, this one has r equals, so here's our example, r equals e to the 3 theta. And let's take that one about theta equals pi over 2, so the old y-axis, so to speak, and 0 is less than or equal to theta is less than or equal to pi over 2. So there's our function. Let's try to figure out what we're going to do with this. And this is kind of a long problem, so it's going to take a bit, but it doesn't look that bad, but take a look at it here. So set up, if we're going to do surface area, capital S is equal to 2 pi. Then we're going to go 0 to pi over 2. We've got the function f of theta, so that is e to the 3 theta, that's f of theta, and we're going about the theta is pi over 2, theta is pi over 2 is this one, and so we've got to put cosine. And then here we've got the square root of the original squared, so that's going to be e to the 6 theta, plus, now I've got to take the derivative of this, so that's 3e to the 3 theta. Then I've got to square it, so 3e to the 3 theta, all squared, d theta. So there's the problem. Simplifying that a little bit will give us this, 2 pi, the integral 0 to pi over 2. We've got e to the 3 theta, cosine theta, and then we've got this. This is e to the 6 theta plus 9e to the 6 theta, so that is actually the square root of 10 e to the 6 theta d theta. Now I can simplify a little bit, but it's not going to be a lot. I can pull out the square root of 10, so I've got 2 pi square roots of 10. I've got cosine of theta, so here's cosine of theta. And here I've got e to the 3 theta, here I've got e to the 3 theta, so that's e to the 6 theta d theta. I'm going 0 to pi over 2. Now this problem, just because it's probably a good idea to practice this problem needs to be done with integration by parts. So I am going to initially let u equal e to the 6 theta. So du is equal to 6e to the 6 theta d theta. dv equals cosine theta d theta. So v equals sine theta. All right, so I start integrating by parts. Let me kind of take this out of context for a minute, because you'll notice that this part, okay, so let me kind of circle that part and call it part I or something. This part is going to need another integration by parts. So it is uv, so u is e to the 6 theta, v is sine theta, minus v du, integral of v du. So v is sine theta, du, 6, I'm going to put the 6 there, e to the 6 theta d theta. Now that makes me repeat my process. So here's what I've got for this one, my new u, okay, so let me just make that look a little different. My new u, I'm going to be consistent here, is e to the 6 theta. So du is equal to 6e to the 6 theta d theta. My dv is sine theta. So that gives me v is equal to minus cosine theta. This had a d theta on it. So here's what we have. We have this part, I, okay, is equal to, I guess I could have put this, I is equal to this. So it's now equal to e to the 6 theta sine theta minus 6 times, and I don't have any limits on these yet, but I've got to go uv, so I've got minus cosine theta e to the 6 theta, and then minus the integral v du. So v is negative, so there's that. Cosine theta du is, there's a 6, and e to the 6 theta d theta. Okay? Now I need to put some things together. This stuff is all equal to, and I'm going to leave the limits off, it's equal to this. It's equal to the integral of cosine theta e to the 6 theta d theta. So now I can take this integral and put them together. So this whole works with no limits on it, is e to the 6 theta sine theta plus 6 cosine theta e to the 6 theta. This is minus 36 of these. So minus 36 of these, I'm going to take that and send it over here. So this now is going to be 37 of these. So cosine of theta e to the 6 theta d theta. And so if I divide by 37, I've got my integral. Okay? So I kind of cut a little bit out of that, but not too much. So now, let's go ahead and finish the problem. So we had s was equal to 2 pi square roots of 10, and then it's going to be this. It's going to be over 37, and then it's got this e to the 6 theta sine theta plus 6 cosine theta e to the 6 theta, and we go from 0 to pi over 2, so I've got to do some calculations. I've got 2 pi square root of 10 over 37, okay? Use a fundamental theorem of calculus, put pi over 2 in here. That gives me 1 here, so I've got e to the 6 times pi over 2, so that's e to the 3 pi times 1 plus cosine of pi over 2 is 0, so this part's 0. Then I'm going to have, so I've got this minus, let me put this down here, evaluated at 0, so this part's 0 now. So 0 plus cosine at 0 is 1. So 6 times 1, and e to the 0 is 1, so plus 6. Okay, so here's what we have. We have 2 pi square root of 10 over 37 multiplied by e to the 3 pi and then minus 6. So there's our arc length and a little bit of integration by parts to boot.